All right, guys, we're going to get started here. It's right 10:30, so I'd like to welcome you guys out. My name is Alfred Lee. I'm Vice President of Product Management at Palo Alto Networks. I've been at Palo Alto now for a little over 10 years, so started before we actually released products. I'm responsible for all of the threat prevention aspects of the device, as well as hardware. So, been here for a little while and can hopefully explain to you how our native threat intelligence drives automated prevention through the security platform. And for some reason, it's not projecting. 1 second. My bad. All right. So hopefully, let's keep it interactive. If you guys have questions, we don't have to wait till the end. We've got a relatively small group. I'm grateful that you guys all came. If this was in Vegas, it'd probably have like 2 people. So happy that it's in Vancouver this time. So we're going to go ahead and get started. And again, if you guys have questions, hopefully we can keep it interactive. It's a relatively small enough group that hopefully I can hear you, and I'll try to repeat the question. And we'll dive down deeper into the threat intelligence as well as some of the stuff that Lee Klarich, my boss, who talked about it on stage at the keynote, about how we're changing the consumption model. We'll talk a little bit more about that with the logging service and the new application framework. So first of all, if we take a look at the time that it takes to actually detect a breach on your network, what you'll oftentimes see, and this is actually data from Verizon's data breach investigation report that comes out every year, and this is from last year's, but they took a look at how much time it took to actually compromise or actually breach a network, and the time that it took to exfiltrate data out, and the time that it took for these organizations to actually discover that they had been breached. And what you'll see here is that it takes mostly minutes. Over 80% of these breaches took mostly minutes to occur. And the time for exfiltration varied, but mostly happened within a matter of days. However, if you look at the time to discovery, it often took weeks, months, and sometimes even years. And so if you ask yourself, why does it take months or even years to actually discover a breach? I think you'll find many different reasons. These are just a few of them. I think one of the reasons is because, one, there's way too many alerts that are coming in, right? People often get desensitized or tuned out to all of the alerts that are coming from all the various security devices on the network. It's not by choice. It's just a sheer numbers fact that resources are you have too little resources to actually go and follow up with each and every single alert that comes up. Also the fact that it's difficult to prioritize, or oftentimes organizations don't prioritize the critical alerts. They're just trying to keep their head above water and looking at what they can in terms of critical alerts. And then finally, in order to investigate, it's not automated. It's a very manual process. And so again, resources come into play that you can't investigate, automate, or remediate against these incidents very quickly. So what's the goal at Palo Alto Networks? Our goal is very simply to be able to actually block attacks. We want to enable organizations to actually be able to prevent on attacks. And we look at it from 4 very simple steps. We think they're simple steps, but there's a lot that goes into each and every single one of them. The first one is that you need to be able to have complete visibility into all the traffic. You can't secure what you can't see. And so if you don't get visibility into the traffic, you have no hope of understanding what's passing through there or any hope of actually securing it. And so it doesn't matter if that traffic is not only on your network, within the data center, going out to private public clouds, going out to SaaS application providers, whether it's users that are remote or on the network. If you have a mobile workforce, they could be at client locations. or at third-party partners that you have. Anywhere that there's traffic coming from your assets or going into critical applications that you host or that are hosted by others, you need to get access and visibility into there, or you have no way of actually controlling it. Second part of it is you need to reduce the attack surface. And what that means is that there may be applications that you can't even secure, that are just bad, that you don't want on your network. Or you want to limit or reduce the amount of applications that a specific user has access to. And so what that does is it reduces the attack surface, or in a way, reduces what an attacker can use to infiltrate or even exfiltrate data out using. And then finally, once you've reduced that, you've reduced and eliminated risk from high-risk applications or applications that you can't secure, that you don't want your users to use, you need to be able to block threats, any type of known threats. You need to just be able to block right up front. And then finally, what you're left with is unknown. And from an unknown perspective, you need a method or a mechanism to quickly turn unknown into known good or known bad. Now, 4 relatively simple steps, but again, there's a lot of technology that goes into each and every single one of those steps. And we believe that if you were to deploy a conga line of security devices on your network, which you call best of breed, and try to put them all throughout the network, you'd have a very messy network. You'd have a lot of devices in line. You would have a lot of complexity in trying to glue them together in terms of making them correlate and work together. And when you're researching attacks or events on your network, it would take a large operational effort to basically say, okay, you go take a look at who had this IP address at this time. You figure out what the firewall saw. You figure out what the IPS saw. Let's figure out what the proxy saw on this. And everybody's sort of running around trying to figure out what happened with a particular attack. And everybody's trying to bring back information and try to match logs up and say, well, the timestamp doesn't match. I don't think that's the right one. Go back and look again. And you're sort of running around, spinning your wheels, trying to figure out the data. We believe that inherently you need to have something that is natively engineered, tightly integrated, and automated in order to block attacks. And so having sort of best of breed and sort of gluing them together, making them work together, does not help you to achieve the goal of actually being able to prevent against attacks. I'll give you an example. So if I left Palo Alto Networks and decided to start a company and decided to say, I'm going to start a company that's going to be the best at detecting known malware. And let's say I took the best engineers out of Palo Alto Networks to help me. How good do you think I'd actually be? You're good engineers, so-so product manager. I don't think I'd be very good because I didn't spend time. I only spent time on known threats. I didn't take time to understand all applications, and understanding all applications, and where applications can send threats, or viruses, or even exploits. I wouldn't be very good because I wouldn't even be able to see through encrypted traffic. I wouldn't be able to decrypt SSL. I'd have to rely on another device on the network to decrypt the traffic and send it over to me. I wouldn't be good because I didn't focus on cloud. I wouldn't understand how to detect threats in public cloud or private cloud. And it's questionable if I would have been even good at detecting known threats if I didn't focus on unknown and investing in technologies to help me quickly turn unknown threats into known bad or known good. So what this translates into is we really need an approach to where all these capabilities are, again, natively integrated together in order to prevent attacks. And in order to have, you need to have consistent capabilities all across the network, no matter where it's at, in order to have the same blocking and visibility anywhere within the network. And the ability to automatically, once you've detected something, to be able to automatically reprogram areas in the key areas within the network that are capable of identifying these threats and actually blocking them in real time. And so that's the value of Palo Alto Networks, is that we've created this platform in order to be able to detect very quickly unknown threats and quickly push out intelligence and reprogram in terms of new signatures out to all the areas that can actually block, whether it's in the cloud, whether it's part of the SaaS applications, part of the network, or even part of the endpoint. So if you take a look at the platform, essentially the threat intelligence cloud operates as the brain. It starts to automatically feed in all this information and figure out how we can take these unknown threats and, as quick as we can, turn them into known and extract the right features or the right context to be able to provide to you, one, more protection, and two, more information and analysis and context around what's happening on the network. So as we talk about what we do from a next generation firewall standpoint, this is not just physical firewalls, but also virtual VM series firewalls that you can deploy in public and private clouds. Also takes into account Aperture, where we get cloud-to-cloud visibility into your SaaS applications. So as your data is moved from your private cloud into SaaS application providers where you don't even own the infrastructure, you don't have any control over where the data sits, what's protecting it, you need visibility into that. And Aperture will give you that visibility and that security overview into it. All of that information gets sent up to the threat intelligence cloud, and we'll talk a little bit about how the cloud continues to change, to analyze the traffic in order to identify new threats. And then finally, also, we continue to receive information from traps as well from an endpoint perspective. The endpoint, we believe, has a unique perspective in that the network only sees things from a transport level. It's just sort of plumbing, network plumbing, right? You have to know about something that's bad in order to block it on the network, because you have to know about it in order to write a signature for it, in order to identify it as it's traversing. The endpoint actually has a much better view into 0 days and things like that, because it actually has to behave in real time. The endpoint can actually see the behavior, the malicious behavior, and can actually have an opportunity to stop it. So from a threat intelligence cloud perspective, it's all about pulling in as much information as you can. The more information, the better. So for us, that visibility comes up within over 17,000 customers that are using WildFire today, that are actively sending files back to us. And what that visibility does for us is it allows us to receive anywhere around 10 million unique files on a daily basis that are being run within WildFire. And so it quickly becomes a network effect for intelligence as we're able to see all these new files and run them in WildFire, detonate those files, understand and come out with a determination if they're malicious or benign, see where they're communicating with, what tactics did they use on the attacker side, were there exploits involved, what are these new 0-day exploits, and quickly allows us to generate signatures. Every 5 minutes, we'll generate signatures based off of all the files that are coming into WildFire and push those down rapidly to firewalls. We let traps also take advantage of that information as well. So from a threat intelligence cloud perspective, here's how you can visualize what we're doing in terms of all the raw information that we're taking in. So we receive raw information from firewalls, of course, all of our devices. We get it from traps, from endpoints that see or run files. We also get it from Aperture, to where you're sending files into, let's say, third-party applications like Box or GitHub or Office 365 and things like that, to where we can also get file information, but we're also pulling in information from other third parties. We want to get as much data as we can, because that, of course, increases our chances to be able to see more threats, and even more clean files actually helps us as well, because we can continue to look at what's known good and what's known bad and continue to compare, and that trains models and things like that. From here, it all gets pulled into WildFire, PanDB, and content updates. And so raw information is not threat intelligence. It has to be processed, right? And so for us, the processing happens on WildFire, where we're taking in millions of files on a daily basis, detonating them. We're using multiple types of analysis, which we'll talk about a little bit later, in order to identify malicious files. We also follow URLs. So oftentimes the URL of where the file came from will also come to us. We'll visit that URL with the browser. We also have the opportunity to look at mail. And so as mail is passing through the firewall, you have the capability of sending links from within mail. We can extract that as it's traversing the firewall, send that up to our threat intelligence cloud, and WildFire will visit that with an actual browser. PanDB will go and crawl that file and look at it from a machine learning perspective to see whether or not it's a phishing page. It may not even deliver malware, but it's a phishing page based on known indicators. And so we'll use machine learning from a PanDB perspective as well. And from here, you also have content updates, which is sort of the derivative of all the analysis that happens to get pushed back into the firewalls. From here, autofocus gets all that information from WildFire and allows you as customers to be able to take a look at all the indicators of what we saw at Palo Alto Networks from all of our other customers in terms of what malware did we see, how often did we see it, what industries did we see this piece of malware attacking, what regions did we see it in, how many times did we see it, can we attribute it back to an attack campaign or an attacker. And so if we can attribute it back to these things, we can take a look at specific unique indicators and group them together by not just malware family, but by attackers. This gives you more information and more context. Unit 42 actually uses autofocus as well. We have Unit 42 researchers that take a look at all the threats and start to do tagging as well, so you don't have to, so you can gain the benefits within autofocus of understanding what we do and what we see in terms of the threats that are attacking not only your network, but also other Palo Alto Networks customers. From a threat intelligence cloud perspective, these are the three main things that we continue to aspire to do. From a detection standpoint, continue to enhance our detection of unknown malware and exploits. From a prevention perspective, continue to drive as much automation as possible in terms of prevention. Manual just doesn't work today. You need to drive automated outcomes and prevention. And then finally is to leverage all types of threat intelligence. It's not just us. We don't have everything in the world in terms of threat intelligence. And so you need to have a method for being able to pull in other third-party intelligence sources and turn that into prevention as well. So from a detection standpoint, as we take a look at what WildFire is capable of doing, it started off as mainly just dynamic analysis. So we used to just pull files in, drop them into a virtualized Windows environment, detonate it, and take a look at the behaviors off of it. As you know, this is a cat and mouse game. Once attackers know that you're detonating within a virtualized environment, they have methods where they look for virtualization evidence that they're running within a virtualized environment. And if so, stop running, right? And so we had to take a look at other methods for analysis. So some of those methods are first static analysis. So just simple static analysis of a particular file is we will actually, as a file comes in, it's very fast. We pull out certain indicators out of the file. We'll currently look at over 1,000 different indicators within a file to see if it looks like malware, just based on a static analysis without even dynamically running it. Another thing that we do is we use machine learning. And with these indicators that machine learning looks at, it's almost like a scattergram. It pulls out all these indicators and plots it to see whether or not it looks similar to other pieces of malware. And machine learning is actually really good at identifying families where you have a lot of variants of the same type of malware, where they've just done minor changes. Dynamic analysis is still good for completely unknown, never been seen before, where we can drop it into an environment and actually run it. And finally, if everything else fails, you need bare metal analysis, which means that there's no virtualization at all. We actually run it the dynamic analysis is actually run in a custom-built virtual environment. We used to use an open source virtualization environment. However, it's the same virtualization environment that virtually all sandboxes in the world will use. And so attackers know what that sandbox looks like, what it does, and can figure out what to look for. By customizing it, we've taken that out of it to say, we own it, we can change it to look however we want it to look, and we have the opportunity to change it at any given time. But even with that, it's still running within virtualization. And so the only way around that is to actually run it on bare metal. And so this is very expensive to use, but we have automated indicators to say to look at files and automatically steer them into bare metal when we believe that it's necessary. So if a file looks suspicious enough, if it does a couple of checks, if it just looks for our hooks in the environment and stops running, then we want to drop it into bare metal analysis to see if it's actually malicious. As we look at prevention, we take a look at all the information that we're pulling in, all the different analysis techniques. What we do is we actually have protections that are pushed out every 5 minutes, and it's just a 5-minute cadence that WildFire has. Anything that's found to be malicious just gets pushed out. And what gets pushed out is not just file signatures, so there are file-based AV signatures that get pushed out with those WildFire updates. We also have command and control signatures that get pushed out every 5 minutes as well. Those could be things like domains, URLs, and things like that. DNS-based signatures, as well as URL or malicious URLs. So not only the file, but also the URL that served it up, even the URLs that are used for command and control. So you can see that there's multiple different methods in which we're pushing out rapid signatures in order to detect and prevent. And this, of course, is a network effect. The more people using it, the more source information we have coming in, the more that we have visibility into, the more threat intelligence and third-party information we can provide. And that gets pushed out from a source perspective, into our threat intelligence cloud. The more we can process, the more we can push out protections for all of our customers, and the more that we can also integrate and automate with third-party integrations, the better it is in order to react to any type of attack that we've seen on the network. And the key here is that it's cyclical, it's highly automated with outcomes to be able to block attacks that are happening on your networks. And so you don't have to be the first one to get hit by something, but you're the beneficiary of everybody else's visibility and everybody else sending things into Palo Alto Networks. All right, we're going to switch gears, and we're going to talk about the next generation of cloud security, cloud services architecture. And this is in line with what Lee Klarich talked about yesterday. And you'll notice that a lot of the slides are very, very similar, if not exactly the same. In terms of the problems that we see in terms of the threat landscape and reacting to it, we see a couple of different things that prevent customers from actually deploying new types of services and new types of hardware. So the first is that with the rapidly changing threat landscape, what we see is that it's difficult for customers to deploy new technology. I mean, if you're focused on prevention, and we hopefully a large portion of you guys are, if you're focused on prevention, you guys know that only inline devices on your network are going to be able to prevent. And so if other devices, security devices, want to prevent, what happens? You've got to go out and convince the network team that you need to put yet another device in line on the network. You've got to go procure that hardware. You've got to go spin up resources in order to hook up your operations guys in order to monitor it, in order to operationalize it. There's a lot of work. It's a lot to also get the workflows for working with multiple devices that are on the network after you've got it installed. And finally, there's just a lot of investment that you have to make. There's a lot of capital expenses, CapEx costs associated with deploying new hardware on your network and new security devices. And you also have to prove ROI, that it's doing what it's supposed to. And so there's a lot of risk in terms of deploying new devices on your network. So with all these, we believe that it's incumbent upon us to actually change that consumption model. So as you heard yesterday, we're changing that. You heard Nir get up there and talk about how we need to change the way that you consume new security. And it can't be that you have to have yet a new vendor sell you another box. And I'm sure you guys don't want to have to continue to have to sell new boxes or to purchase new boxes and convince your boss and the CIO that you need more money to purchase new devices that you're going to put on the network that might make the network slower. And you have, of course, the bottleneck of other network security guys that don't want, or network guys that don't want it on the network. So what do we have in terms of logging? This is a foundation of what we're able to do as part of this new service. The first is that you need to send as much information on what's happening on the network as possible to a centralized location. We believe that we have the richest set of log data in the market in terms of what we see, in terms of what we detect, visibility into the applications, visibility into the users that are using those applications, visibility into the threats that are traversing the network from those users over those applications, all over the network. So front-ending your data center, your internal applications, front-ending your network perimeter, seeing all the traffic that goes in and out of the network. All of those logs that are created from those firewalls or VM series need to be sent up into this logging service. So whether it's at headquarters, at the branch, office, everything needs to be sent up. What that will do is it'll give all the visibility and intelligence of what Palo Alto Networks has seen into a centralized location. So this logging service is essentially the backbone of visibility and threat intelligence or threat logs from all across your company and all across your networks. It also, one other thing, it also allows you to quickly scale up logging. As Lee talked about, it's really, really easy to basically say, give me 100 terabytes of log storage up in the cloud, and it's done. You can do it directly from Panorama. From here, once we have all the logs, essentially from your entire network, from your endpoints, and from the cloud, everything within the logging service is what we get to build the application framework on top of. So what we're talking about here is the fact that we're allowing not just us to develop applications, other third parties develop applications, even customers develop applications on the application framework to get access to the logs. And what that means is that we're fostering a lot of innovation in terms of getting inline visibility and what can happen through the application framework. And so you can now consume security through cloud-delivered applications by leading and even startup security providers with minimal or no risk. Essentially, once you have the data within the logging service, you can take a look at all of the applications that are available, and you can automatically just say, yeah, that's good. Let me try this for 30 days. I assume that they're going to give 30-day trials where you can just say, let me try that for 30 days or 14 days, and let's see what it can do, right? With real network data, with all the visibility that we provide, within the logging service, you can take a look at it to provide additional security capabilities with no additional infrastructure costs to you. And so what we do is we allow, whether it's third-party partners, whether it's our apps or customer apps, access into your specific customer data store. So only access to your logs, and you can decide what type of logs to give it access to. And now we can continue to develop better and newer security technologies and focus on that without having to have everybody develop new hardware that you have to deploy on your network. So as we take a look at the apps that we have, so the first 3 applications that are going to be developed or available on the application framework are Autofocus, MindMeld, and LightCyber. So Autofocus, as you know, is our threat intelligence service portal where you can log in, you see all the information that we see in terms of attacks, the behaviors on them, you can correlate, you can take advantage of Unit 42 intelligence and tagging. MindMeld allows us to syndicate all of that information, allows us to aggregate other third-party information coming in. It'll also allow you to be able to do retroactive visibility, to go back and look through and see if you had anybody in the past hit those indicators. So if you see an indicator that's interesting, go back and look at all of the logs to say, hey, has anybody gone to this URL or communicated with this domain within the last 7 days, 30 days? And go back and retroactively look at all the logs. Also be able to pull in other third-party information from other third-party intelligence providers. And then this is also the area in which we're going to have LightCyber. So LightCyber will be also one of the first applications that we provide on there. And so background on LightCyber is we acquired LightCyber, which is a user behavior analytics company that does phenomenal work in terms of being able to do deep packet inspection on the network and run analysis to figure out what's normal behavior for a particular user on the network, and then look at anomalies or deviations from the normal behavior to identify attackers that have already landed and are operating within your network based off of the baseline. You can also compare the user with other peers. Are they behaving differently to their baseline behavior usage, or how differently are they behaving from other people, their peers within their group, within the same organization? So LightCyber is going to be delivered as a cloud-based service. So essentially, you don't have to purchase new hardware, new LightCyber hardware to do the deep packet inspection on the network, send it to another analysis device that's on the network. The Palo Network's firewalls will essentially do all the collection, all the deep packet inspection on the network, put that into logs, and those logs go up to the logging service, which now, if you want to use user behavior analytics, all you have to do is turn on the service or pick up the service with LightCyber, and automatically you have user behavior analytics running across your entire network or whatever is feeding logs into the logging service. You can start to imagine what other third-party apps might be delivered over the data. And so what we envision is that there are other threat intelligence companies out there, many of them that you have today, that you subscribe to, but it's difficult to tie it into all of your security devices. Guess what? They can tie into the application framework, provide the threat intelligence to you as a service, and now through the application framework, they can actually send down actions associated with it. If you have positive hits associated with it, you can now have a method to be able to initiate a playbook or initiate actions to take action upon the intelligence that you have. You also have other analytics. We know that we're not the only ones that can analyze for user behavior. There are going to be other companies that do it. And you heard Nir yesterday say, even competitors. We will have competitors that will develop other analytics applications that might compete with us. And might compete with LightCyber. It's okay. If they're providing more value, This is great. It's better for our customers. Automation. From an automation standpoint, being able to take logs and look at outcomes of what you want to automate, what actions you want to automate. There will be automation companies. There are going to be EDR, things that are focused on IoT security, and so on and so forth. There's going to be a lot of different types of applications that will be provided out of the application framework that will provide value from a security standpoint. And that also allows you to be able to create custom applications solely for your use or for use with other folks if you wanted to. With the application framework, it's only as good as the ecosystem that provides applications onto it. And so the initial group of companies that have committed to providing an application on the application framework are these. You have large companies like IBM, like Proofpoint and Splunk, Booz Allen, Hamilton. All of these companies have committed to creating applications, but you also have smaller companies as well, whether it's Phantom, Tanium, Recorded Future, Threat Quotient. We even have people that might be considered competitors, like CrowdStrike, right? From an endpoint perspective, might compete with Traps. All of these ecosystem partners we're going to embrace by giving them the same amount of data, and allows everybody a level playing field in terms of how good can you be with the same amount of data, right? Is your analysis better? And will allow companies to be able to focus on their differentiation without having to worry about, how do I get onto your network? How do I create a device that's transparent enough to just drop in line? Does it have the right redundancy? Because you need to put it in line for blocking. They don't have to worry about any of that. They can focus on just security differentiators and working on their software. So Lee went through this example and use case, but I'm going to go through it again really quickly so that you guys can understand what the capabilities are with having multiple independent software vendors be able to create a use case in which you have better outcomes associated with the security. So first, if we start off with detecting an anomaly. So this is LightCyber. LightCyber is running, looking at all the logs that you've sent in from all of your Palo Alto Networks devices. And LightCyber has gone through and individually, from a user perspective, created baselines for the user behavior. LightCyber detects that one of your users is doing something very anomalous to their behavior and throws up a flag and says, hey, I see this anomaly with this user on the network, and it gets sent over to MindMeld. And MindMeld starts to take a look at the indicators and can do a retroactive search across the entire network, can pull in third-party feeds to corroborate and say, yes, this looks like an infected host based on these IOCs that I've also seen coming in from my other third-party feeds. You can also take that information and send it out to other colleagues as well. From here, MindMeld can also send it over to Recorded Future. Recorded Future has visibility into, let's say, dark web, and can say, hey, this indicator of compromise was actually seen on a dark web forum attributed to a nation-state attacker. This exact single IOC, which then would raise the risk score and say, hey, this is really bad. This is not just bad. It's really, really bad because we saw these IOCs associated with the nation-state attacker, and can then send that over to yet another ISV in Phantom. And Phantom, which has playbooks, can say, with these really bad things, we need to run this playbook. And what that means is that there are certain automated actions that need to take place when we see this type of criticality. And so it might say, hey, we're going to lock down and quarantine this user. We're going to send information down to the multi-factor authentication folks, whether it's Duo, Ping, or who else is there? Duo, Ping, any of the guys that work with authentication. And actually be able to say, hey, from a directory perspective, we don't want this user logging into the data center, into these key systems. And then finally, you can also, after it's all said and done, you can kick it over to ProtectWise, which can then actually provide visualization of the actual attack itself. And so from here, you can start to understand how powerful this can be, that you can string together these multiple disparate applications all within the application framework, and allows you that visibility. And imagine what you'd have to do manually if you were to have instantiated each and every single one of these as separate services, and then have to have the operational resources to be able to go through and research all of these independently. So there's value for our customers, which is superior security with not just Palo Alto Networks, but with the application platform that we have, allowing others to innovate across the data and the visibility that we have. Will increase the security of what we can do. It's not just Palo Alto Networks that gets to innovate off of this data. We're going to open it up to everyone else out there. More application collaboration, single workflows, allowing for different providers to do the identification, the analysis, and also response actions. And then changing again that consumption model to a SaaS-based consumption model, to where you can quickly, again, try out new applications across the data, try them out for a little while. It doesn't work for you, you can try another vendor without having to, again, bring in hardware, set it up, put it on the network to try it out. It's as simple as, I want to try these applications now and turn them on and see how they do, and offers more predictable operational expenses as opposed to a bunch of CapEx spend, right? You're able to take this and say, I can turn it on, it's an operational expense, and turn it on for a month, see how it does, prove it out, show the outcomes to your boss or to your CIO, CISO, to show that it actually provides value, and this is what the operational cost is going to be. There's no additional network or maintenance costs that are ongoing. There's a huge value for application developers in which you can continue to take out the complexities of an actual company going to, of course, develop all these new platforms that go on your network. They can take all of that out. They get access to much more data, and not just their own. It's Palo Alto Networks. It's data from other third parties. And then also the speed to market, right? They're able to focus on their core differentiators without having to worry about all of that, and can actually come to market much faster with a SaaS-based model. We announced yesterday that there is a venture fund with two of the best venture capital companies within the world, Greylock as well as Sequoia, are initiating a $20 million innovation fund, which will fund companies that develop applications to run on top of our application framework. So finally, from an application framework perspective, we believe that this is a huge shift and a huge change in the market. As much of disruption that we had 10 years ago when we first came out with the next generation firewall, where we completely changed the security landscape by coming out with application visibility and control, we believe we're doing the same thing here with providing the application framework to provide new and faster development of applications that can provide better security and better security outcomes for your organizations. And again, it allows for more innovation. And it's not just us that's doing the innovation, it's everybody else out there that's innovating across the application framework. All right, we're going to open up to questions. We have probably 6 or 7 minutes left in the session. So we're going to open it up for whatever questions you guys might have. So the question, I'm not sure if everybody heard or not, the question was regarding LightCyber and whether or not it's a requirement to use the logging service in order to get the logs up to LightCyber. So you have to use the logging service. The logging service could be sent from individual firewalls or even from Panorama. And so we have to have the log data in the logging service to be able to run LightCyber analysis on the logs. But how you get it there could be from Panorama or it could be from the individual devices themselves. So the question is the logging service a replacement for SIEM? Is it a place where you can just send a bunch of data up to? So we're not a SIEM. This is a logging service specifically for Palo Alto Networks devices. So SIEMs usually take in logs from a whole bunch of different devices. Right now, this is only for us. It is only for Palo Alto Networks devices. That's correct. Yep. Yep.
The firewall itself logs your stuff. Is this adding to that or replacing that?
It will take the same. Oh, sorry. So the question is, the firewalls log everything that it sees and things like that. Is this additive or is this a replacement? So it's taking those exact same logs. We are enhancing it for LightCyber. We're doing certain other types of logging specifically for LightCyber. So in addition to the logs that we have today, in the next version, Budapest is the code name for that PanOS release. In Budapest, we will have other logs specific to LightCyber, but it'll contain all the same logs that you have now, and that's going into the logging service. Yep. So it's that and more for LightCyber. Does that make sense?
How is access to the logs in the log service protected or controlled? Or is there tokenization going on? I mean, how do I know who's accessing, who's able to access those logs?
Yeah, so the question is, how do we secure the logs and make sure that only you have access to your own logs and nobody else has access to it? So the way that we've created the cloud, and it's the same thing for even WildFire, to where when you send files up to us, only you have visibility into those files, right? It's still going into WildFire. It's segmented based on the customer. And so there is no contamination across the devices. And we'll put out, similar to WildFire, we'll put out a security sheet which tells you what we've done to make sure that the data is segmented and it's protected from anybody else getting access to it. But we have experience in doing it with WildFire, and we'll do the same thing here to have individuals' data siloed, if you will.
How much of that, of the logging service data is provided to the third party?
How much of the
logging service data is provided to the third party application?
You will give them access to your applications, to your log data. So you can decide what gets logged. So all of the customers will have, similar to the logging profile that you have now, right? It's by rule. You can decide what you want to log associated with each and every single rule. And so what gets sent up is what they will have access to in terms of the logs. So you still have control of what gets sent, and they'll get access to all of that. Generally, of course, it's better to send. The more data you have up there, the more analysis, of course, that you can do. So we have like 3 minutes is a sign that I got. So time for a few more questions. Great. If not, I'll be available after the session. So thank you for coming. I appreciate it.